Welcome everyone. Today we are diving into the exciting world of data structures and algorithms. Understanding these foundational concepts is crucial for any aspiring program, as they form the backbone of efficient and elegant solutions to a wide range of problems. In this video, we will be focusing on one of the simplest yet incredibly powerful data structures, the stack. We will explore what stacks are, how they work, and most importantly, how to implement them in Python programming language. Whether you are a beginner looking to solidify your understanding or a seasoned developer seeking a refresher, this video has something for you. So, without any further ado, let's dive in. So, the first topic we are going to cover in this video is the implementation of stack. The first question is to implement a stack data structure in Python programming language, including all the basic functionalities. Ensure your implementation can handle edge cases. Before diving into the implementation, let's understand what a stack is. Stack is a data structure that follows last in first out or LIFO principle, meaning the last element added to the stack is the first one to be removed. So let's consider this as a stack and which contains elements A, B, and C. In this stack, when we implement pop function, the first element to be removed will be the C. That will be the last element we have pushed into the stack. Think of it as a stack of plates. You add a plate to the top of the stack, and when you need one, you take it from the top. Don't take it from the bottom right. Now let's discuss the basic operations of a stack. First, we push, which adds element to the stack, like A, B, C. We push the elements to the stack. Then comes a pop function, which removes the last inserted element from the stack. The next function is peek, which allows us to view the top item without removing it, while isEmpty is a function that checks if the stack is empty or not. And there is a optional function called size that which tells us the size or number of the elements contained in the stack. When implementing a stack, it's crucial to consider edge cases like overflow and underflow. Overflow occurs when we try to add more elements to the stack than its maximum capacity that allows. While underflow happens when we attempt to remove an item from an empty stack. Handling these cases ensures reliability and robustness of our implementation. For this demonstration, I will be implementing a stack data structure in Python programming language. So without any further ado, let's dive into the program and check the implementation. For the coding part, I am using here is Visual Studio Code. You can also use ideally Python or any other program that can be used. Implementing stack using Python. First, we have to initialize a class named stack. In this class, I am going to define a function name and double underscore init double underscore. This function is used to create an empty stack. Self dot stack equals to empty list. The next function I'm going to define here is empty in bracket self. This function is used to check whether the given stack is empty or not. Return self dot stack equals to empty list. So this will check whether the given stack is empty or not. The next function I'm going to implement is push, which adds elements into the stack. In bracket, we have to add self and items in which we have those items we have to insert into the stack. The code is self dot stack dot append for items. So this will insert items into the stack. The next function I am going to define is pop. In bracket, we have to mention self. In this function, the last element will be popped out. So if the stack is empty, it will produce an error. So we first have to check whether the given stack is empty or not. Not self dot is empty function bracket return self dot stack dot pop function bracket. It will remove the last element. If the stack is empty, we will print a message that the given stack is empty. So the next function is speak bracket where I'm adding self. This is used to view the last element of the stack. So here also we have to check whether the given stack is empty or not. So if not, self dot is empty function bracket return self dot stack of -1. Else print an error message that the given stack is empty. Stack is empty. The last function I am going to add is size, which returns the size of the stack or the number of elements inside the stack. The code is return length of self dot stack. For our convenience, I am making this as a menu-driven program. So self is stack is equals to stack was. So the menu-driven starts like while true print give a fitting for understanding stack operations. Print the first option is push print. The second one is pop. And third one is peak. Then comes the fourth one, size. Then the last one is which helps the user to exit from the loop. So if we give int, it will give error when we put something string. So it's better to keep it input. So any other than the given 1, 2, 3, 4, 5 is inserted, it will provide an error. Put enter your choice. If choice equivalent to 1, we have to first provide item, right? Item is equals to input and the item to push, item to push, then stack dot push of item. It will insert the item into the stack. The next elect choice equivalent to 2. So it's better to show the popped item first. So before popping, we have to assign this popped item to another keyword. Pop item is equals to stack dot pop function. It will store the popped item into the popped item. Okay. Popped item print popped item. Comma popped item. The next one is elif choice equivalent to 3. Peak item. Peak underscore item is equals to stack dot peak function bracket. Stack dot key. Sorry for the mistakes. Stack dot key. If peak item print peak. If peak underscore item print top paper. Top item is it will print the top peak light. The next one is the size. Choice equivalent to 4. Then the size of the stack, size of the stack, comma, comma, stack dot size. Function bracket. The last one is which helps the user to exit from the loop, right? Stack elif choice equal to 5. The sprint exiting program that given a stage print exiting program. Okay. Then break. uh, if else, so that all other input rather than these will give an invalid message. Current invalid choice, invalid choice, please enter a valid option. And right, um, option. So this is the program that shows the work implementation of functions inside a stack. So let's just run this program once. The first option that I am going to select is push. So just insert some elements into the stack. I have inserted around five elements into the stack. Now let's just pop the last element. Yeah, the popped item is 5. The last element I have entered is 5, and the element that is popped first is also 5. Then we can just peek into the stack, and it gives the output of 4. That means when 5 is removed, the top item, the last item, it becomes 4. The fourth option is size. It returns the remaining elements inside the stack. The size of the stack here is 4. Then the last option is to exit the program. Yeah, our program is working normally. And let's now just move to the next question. Write a function that determines if a given string of parentheses is balanced. A balanced string has opening and closing brackets that match each other. Use a stack to implement your solution. A balanced string of parentheses has each opening parenthesis and matched with the corresponding closing parenthesis in the correct order. Think of it like nesting boxes. Each opening box must have a matching closing box to maintain balance. Like if a right opening square bracket should be closed with a left opening square bracket, right? Like this right opening curly bracket should be closed with left opening curly bracket. This one should be closed with this. Like this, a corresponding closing and opening bracket should be there to be balanced. To solve this problem, we will use a stack data structure. The idea is simple. As we traverse the string, we will push opening parentheses onto the stack and pop them off when we encounter the corresponding closing parenthesis. If at any point we encounter a closing parenthesis with no matching opening parenthesis in the stack, or if there are unmatched opening parentheses remaining in the stack after traversing the entire string, the string is unbalanced. So let's now dive into the code implementation in Python. At first, I'm going to define a function named is balance. Inside the bracket, I am going to initialize a variable named parenthesis. At first, I am going to initialize an empty stack followed by an opening bracket. It is a set of all the opening side brackets. Opening bracket, so opening star bracket, comma, opening curly bracket. Similar to the opening bracket, the closing bracket is also a set of all the closing side brackets, closing side brackets, comma. And now I'm going to define, initialize a dictionary to map closing brackets to their corresponding open brackets. So bracket pairs, bracket underscore pairs equals to dictionary value equals to the opening set, comma, closing set is to the opening set, comma, closing set of the bracket is to the opening set of the bracket. Now I am going to create a loop using for to iterate through the parentheses for brackets in parentheses. Yes, okay, brackets. So I'm now going to check whether the brackets is also in the opening set of the brackets. If so, I want it to get appended inside the empty stack dot append of bracket. Edit brackets brackets in closing brackets. So it's in closing side brackets also. If so, we'll write the code as if no stack or stack dot for function bracket non equal to bracket chaos. So brackets. Then it will return a false message. At last, it will if the old condition is true and true, it will return true. The above part will be used after traversing the entire string if there are still unmatched opening parentheses remaining in the stack. We return false. Otherwise, we return true, indicating that the string is balanced. Now I am going to call these functions print is underscore balance. Uh, let's insert something on some balanced and unbalanced is balanced. Print for balanced. Let's just run this program. It provides the correct output as expected. So the program is running very well. I hope you understand this concept. Now let's move on to the next question. The next question we are going to solve here is design a function that takes a string as input and returns the reversed string using a stack. Reversing a string simply means changing the order of its characters, so the last character becomes the first and the second to the last becomes the second and so on. We will leverage the last in first out property of a stack to achieve this. It simply means that if we create a empty stack, the consider the inputted string as ABC is equals to A, B, and C. Consider this as the inputted stack. Using for loop, we can iterate through this variable A and store these string into the stack using push method A, B, C. So if we initialize a variable v or something name doesn't matter variable using pop method, we can We can pop out these elements in the stack and store it to the variable v. As we all know, when pop method is implemented, the last element inserted will be popped out first. So in this stack, the last element C will be popped out first, then followed by B and A. Through this method, we can reverse the string using a stack, using stack implementation. Now let's dive into the Python implementation of this program.
This program is on reversing a string using stack. So at first I am going to define a function named reversed string. In bracket I am going to add a variable named input string. Input string. At first I am going to initialize a stack, empty stack, and for using for loop I am going to iterate through the input string. So for char in input string, then the char is appended into the stack. So stack dot append in bracket, not input, sorry, char. Then I am going to initialize a empty variable named reversed string, so that all the pop out elements can be stored inside reversed string. Reverse string empty. Then I am using while to initialize a loop till the stack becomes empty. While stack. Then reverse the string plus equals to stack dot pop. That means the last element popped out from the stack will be inputted first into this reversed string. Then I am going to return the reversed string. So through this method we can reverse the string using stack. Then I am going to now call the function reverse string. In bracket I am using hello. So if we run this program, we get an output as OLLEH. So this program works very well. I hope you understand the concept behind this. So I'm concluding my video. Thanks for watching till the end.